All right, guys, let's get started. This is notes on how to use the unit circle. So even if you hadn't been here in a couple of days, hopefully you were here for how to build the unit circle. If not, you need to go back and see how to do that. So this is the first page of unit circle, of using the unit circle, and this is just a quick review. Remember that sine is the y value and that cosine's the x value, and tangent is y over x, or sine theta over cosine theta. Now, knowing that tangent is equal to sine theta over cosine theta can only help you if you can remember this. This is a 5-star statement. You will see this again and again and again. You need to know this, all right? And so cosine is not the inverse function, but it's the reciprocal function. I am guilty for calling it inverse function. It's reciprocal, not the same as the inverse. So it would be 1 over y because it flips, the sine. And it flips the cosine, which is 1 over x, all right? And cotangent just goes in the other order, or cotangent theta is equal to cosine theta over sine theta, okay? So with that said, we have some strange things in the unit circle that we have to flip. So 1/2 goes to 2, and you're like, yeah, I got that. That's easy peasy. The square root of 2 goes to just the square root. And why is that? Because the original was 1 over the square root of 2, but the rationalized form looks like this. Square root 2 over 2. So when you flip it, it's just the square root of 2. All right? The square root of 3 over 2 is 2 times the root of 3 over 2. This one is for the same reason. This was 1 over the square root of 3, which became square root of 3 over 3. 0 becomes undefined because if we put 0 over 1 and we flip it, guys, friends, don't let friends divide by 0. So don't do it. This is undefined. All right, and 1 just becomes 1. So this is a pretty important chart that you may want to remember. It can help you. All right, going on. So how to use the unit circle. First, find the angle on the unit circle, whether the angle is radians or degrees. Then do what the trig function says to do. You're like, okay, that was too easy. All right, so here we go. What I did is I have pulled a unit circle in right here, and it's all completed for me. And so I'm going to go and I'm going to find cosine of 45 degrees. So first, go to the angle, 45 degrees. It's right here, okay? And I'm going to find the cosine of that angle. Okay, remember, this is cosine, sine. It goes in alphabetical order, or good old C.S. Lewis was my favorite writer, so that's his initials, C.S., cosine, sine. So I'm going to go back to this 45, and the cosine's the first one. So it is the square root of 2 over 2. If I go to the next one, I do sine of 330. So I go down here, here's 330 right here. Find the sine of 330. Remember, it's cosine, sine, so it's the second one, so it's negative 1/2. To find the cosine of 240, I go to 240, it's right there. Cosine is the first one, it's negative 1/2. Then I'm going to find the sine of negative 90. Now, I want to show you this. It's really cool. Here's 90 degrees. So the negative for any of these, like negative 60, negative 45, negative 30, any of these that you want to find the negative of, flip it across the x-axis. If you flip this and reflect it over the x-axis, it's this one. So that means 270. So look at my values for 270 degrees. The sine is the second one, so it's negative 1. The sine of 495, well, that doesn't fit on my chart because it stops at 360. So that angle's way too big. So I'm going to take off a 360 degrees. That leaves 5, 3, 1. Oh, so it's the same as 135. So it puts me over in the second quadrant. Now I'm going to find the sine of this, and the sine is the second one, so it's the positive square root 2 over 2. Cosine of 3 pi over 2. Oh wait, 3 pi over 2 is the same as 270. Cosine's the first, so it's 0. Sine of negative 5 pi over 6. And remember what I said. Here's positive 5 pi over 6 right here. So I'm going to flip and go to the pi over 6 that's down below, so it's the same as this one. So the sine of that is the second number of my ordered pair. It's negative 1/2. Cosine of 960, holy mackerel, that's big. So I'm going to subtract 360. Let's see if this is small enough yet. Oh, 600, not small enough yet. I'm going to subtract 360 again. That leaves 40. And I had to borrow 1 from this one, so that becomes 5 minus 3 is 2. 240 degrees. So this is equal to cosine of 240 and cosine of 240. There's my 240 right here. All right, cosine's the first one, it's 1/2. Are we good? All right, now what I'm going to do is grab hold of this guy and copy him. I'm going to paste him on this next page because I can't do it without it. So Control Paste, here he is. All right, and now I can do these problems. Okay, I kind of realized that I left this out at the top of the page. Cosecant is 1 over sine, and secant is 1 over cosine. And I really wish these had thetas in them, but oh well, because it's always of some kind of angle. Otherwise, it wouldn't be worth taking. All right, cosine theta, secant theta. All right. All right, so cosecant of 45 degrees. So first of all, what I want to do is I want to write cosecant as 1 over sine. Well, let's find the sine. Let's find sine of 45 degrees. So here's my 45. And if I take sine of 45, sine is the second. Remember, I'm going to write C.S. Lewis right here. Good old C.S. All right. So sine's the second one. So square root of 2 over 2. And I have to flip it to get this one up here. So this one is 2 over the root of 2. I'm going to show you this the first time, and I hope you can learn to take the shortcut. Take the square root of 2 over 2 times take square root of 2 over square root of 2, okay? Multiply it because that's what we had in the denominator. So what happens here, don't cancel anything. You get 2 times the root of 2 over, well, root 2 times root 2, this is the whole reason we did it, becomes just 2. Oh, wait a minute. Do you see how right here we have a 2 and a 2? All right, they get to cancel, and the final answer is just the root of 2. If you remember back on the first page, we mentioned that. So now we're at secant of 150. Well, secant, I need to know what cosine of 150 is. So if I go over here, here's 150. Cosine's the first one, so I have negative square root 3 over 2. So that means I'm going to flip it for this one. So this is equal to negative 2 over the square root of 3. But to rationalize, I have to multiply by the square root of 3 over the square root of 3. And I hope you know that gives you 2 times the root of 3 over 3. If you're wondering why, you need to come in and ask me and get me to show you how to do that again. All right, so cosecant of pi over 4. Cosecant's the same as 1 over sine. So I want to find sine of 4 pi over 3. 4 pi over 3 is right here. Sine is the second one. It's negative square root 3 over 2. Wait a minute. That's what we had up here. So I already know my answer is going to be negative 2 square root 3 all over 3. Okay? Because I multiplied, when I flipped it, I multiplied the top and the bottom by the square root of 3. Secant is the inverse of cosine, so I'm going to find cosine of 3 pi over 2. 3 pi over 2 is down here at the bottom. So cosine is the first one, and that's 0. So there's cosine. This equals 0. And if you want to put 0 over something, it's over 1, right? So secant is going to mean I flip that. Oh, wait a minute. I cannot have a 0 on the bottom because friends don't let friends divide by 0. So I am going to take this and say it is undefined. Okay? All right, going on. And I've got to have another one in here again. Hold on. Paste. There we go. Now, tangent is, I remember it as sine over cosine. Instead of remembering it as x over y or y over x, sine over cosine is better because you're going to see it in units to come. So this is cosine over sine. All right, thetas, of course. So now when I go to find tangent, now tangent, cotangent are a little different for me. I'm going to go to 60 degrees and I'm going to write down the ordered pair. The reason why is I have to use both of them. All right, so I'm going to go to 60 degrees, which is pi over 3, and I have 1/2 and square root 3 over 2. All right, so if I'm at 60 degrees and I'm finding tangent, remember this is C.S. Lewis, cosine sine. So that means I have to put the sine, which is the y, over the x value, the cosine. So this is equal to the square root of 3 over 2 all over 1/2. All right? But if you remember, when we divide fractions, it's keep, change, flip. So that means I'm going to change this bottom. Let me change colors. I'm going to take this bottom number and I'm going to make it multiplication. That's the change. And now I got to flip it. 2 over 1 equals. All right, so now what I want to do is go in and cancel anything I can. Cancel, cancel. I end up with the square root of 3 over 1 or just the square root of 3. I'm done. Tangent pi, well, pi is located at -1, 0. So if this is cosine sine, that gives me 0 over -1. Guys, that's 0 all day long. It's not undefined. 0 is an okay answer. Cotangent of 5/4. I need to write down what cotangent of 5/4 pi is. 5 pi over 4, well, it's right here. There's 5 pi over 4. So I have both negatives. Negative square root 2 over 2, negative square root 2 over 2. Well, guys, if I have they're exactly the same thing, what is anything over itself? And I do know this is cosine sine, but since they match, I wouldn't know if you did it right or if you did it backwards, because you're going to get this. Now, anything over itself, you should know is 1. All right? Cotangent of 0. Well, that means we need to go to 0. Here's 0 degrees. Okay? 0 or 0 degrees. It's the same thing. I have 1, 0. Now remember, cosine sine and cotangent gets cosine on the top. So this is equal to 1 over 0. All right? And that's undefined. Because friends don't let friends divide by 0. Undefined. All right. Okay, let's see if we can do one more page. How many do I have? I think I can finish this. It may be 20 minutes, but I'll finish it. Okay, so let's put in control paste. Let's find the sine of 750. And first, I've got to subtract 360. I've got to get it to a manageable size. That's 90. That's 390. That's still bigger than 360, so I've got to subtract 360 again, and now I'm at 30 degrees. So all I have to do is go to 30 degrees, and I find, what do they want? Sine. That's the second one, because it's cosine, sine, C.S. Lewis, so that's 1/2. And I'm done. Cotangent, I'm going to write this down. Now, what I'm going to do is I'm going to go find negative pi over 6. I'm going to find positive pi over 6. Here's positive. I'm going to change colors. Here's positive pi over 6. So negative is the same as this one. So that's the same as 330. All right, so I have square root 3 over 2 and negative 1/2. And cotangent is cosine over sine. Tangent is sine over cosine. So the cotangent, cosine go together with the cosine being on top. So this is square root 3 over 2 over negative 1/2. Now I'm going to change flip. So that means I'm going to change division to multiplication, and I'm going to flip 1/2. 2 over 1, and I have a negative there, so I got to keep my negative. I just took care of this one. All right, so cancel what I can, and I end up with the negative square root 3 over 1, or just negative square root 3. Tangent of 3 pi over 4. 3 pi over 4 is right here, so I'm at negative square root 2 over 2 and square root 2 over 2. And so all I have to do for this one is do sine over cosine, so that's the positive one, over the negative one. But here's the thing, they're the same, I just have one negative involved. It's negative 1. I don't have to change flip for my purpose, but you may need to. So secant is 1 over cosine, so I want to find cosine of 30 first. So I'm going to go, here's 30, and the cosine is square root 3 over 2. And then I'm going to flip it. So this is equal to 2 over the square root of 3. Wait a minute. I can't have a square root left in the denominator. I'll show you real quick. Multiply by square root of 3 over square root of 3. Here's one completed for you. Guys, you've got to remember, anytime you multiply a square root by itself, it undoes the square root. Next. Okay, so for this one, what we need to do, and I don't know if I can get this. Oh, yes, it worked. All right, so if I'm at 150 degrees, this says find all 6 of them. So if I'm at 150, here's 150, I'm going to go ahead and write square root 3 over 2, and that's negative, sorry, and 1/2. All right, so this is cosine, this is sine. If it wants to know sine, that's easy. 1/2. Cosine, negative square root 3 over 2. Tangent means I'm going to put the sine over the cosine. So you are going to have 1/2 times, because I'm going to do the inverse, the cosine flip, because it's usually sine over cosine. So I'm going to change, and I have to flip the cosine. I flip the cosine exactly. That canceled. I ended up with 1 over negative root 3. Well, guys, I have to multiply by root 3 over root 3, which gives me negative root 3 over 3. Okay? Cosecant means I'm going to go back to sine, and I'm just going to flip sine. 2 over 1. Secant means I'm going to go back to cosine. I'm just going to flip it. So I get negative 2 over the square root of 3, which is negative 2 root 3 over 3. You have to rationalize. Cotangent means that I want to take cosine over sine. So that leaves me square root 3 over, I need a negative in there, negative 2. And it would be divided by, but I have to do times, and it's cosine over sine, so I'm flipping the sign, 2 over 1. The 2's cancel. Don't lose that negative though. That negative still counts. All it leaves me is the negative square root of 3. All right, what's really cool is look back here at tangent. We had 1 over the negative square root of 3 to start with. Now I ended up with the negative square root of 3. Technically over 1, I just don't always write over 1. I usually leave that off. Okay, 360, I have 1 and 0. So on this one, we're going to have the sine, the cosine, and the sine, and we're going to fill it in. But what I want to do is stop the video, and what I'll do is I'll come back and make this super short video showing you the very last one. Or what if I just posted on It's Learning with all the filled in answers? How's that? I will just repost this as an answer key. All right? Have a good one.